Okay. The flavor of this talk is slightly different than the previous one. So in the previous one, the speaker went into depth into certain problem, gave a very nice like depth-related presentation. So this one focuses more on breadth. So in this presentation, I will talk about content understanding in feed recommendation. Speaking of myself, I was in the Bay Area between 2010 and 2018. Used to work in a number of different companies in the Bay Area before I went back to China. So these days I spent most of my time in China and come back for occasional visits. So the majority of this talk will be based on what I'm doing in Microsoft newsfeed content understanding team. So since I'm only 6 months into this role, so in this presentation, rather than talking about what we have delivered, we are more talking about the problems I see and the challenges we are facing. So I'll be posing more challenges rather than providing solutions. But if you have any detailed questions, so feel free to raise the questions and we can discuss. So a little bit introduction of myself. I have a PhD degree in statistics, and I have more than 10 years of experiences working as a data scientist and as a machine learning engineer in various companies. Throughout my career, I have been mostly working on consumer-facing products. The problem space includes search, advertising, recommendations. So this is the primary space of problems I have been working on. My previous role was director of data science at Kuaishou. So for those of you who are not familiar, so Kuaishou is the #2 largest video sharing platform in China. Next to TikTok, like Chinese version of TikTok. And based on the Q2 earnings report, Kuaishou has 347 million daily active users. And also the average daily spend is 125 minutes. So amazingly, people spend an average of more than 2 hours on this short video platform. And when I was at Kuaishou, I was leading a team of data scientists and analysts and work on 3 areas. The first area is video creation. We are trying to understand why the creators on our platform create videos. So we are trying to improve content creation from 3 aspects. The first aspect is to find out their motivation. So why do they want to come here and produce videos? And the motivation is that based on consumption, try to mimic what they see or having some social purposes. So they try to socialize with their friends. The second area we approach is feedback. The creators on our platform, they receive feedbacks. They receive the number of clicks, the number of likes and comments. So these feedbacks will incentivize our creators to create even more and better quality videos. And the last is to look at the entire creation funnel. So from when the creator clicked on the create menu button until they successfully upload a video. So try to look at the funnel and see where we can improve in the funnel. The second area is in search. So in search, we were focusing on both search growth and the search quality. So for search quality, we are working on evaluation, defining evaluation metrics for search. We are also working very closely with engineers in the search team, try to find out problems in relevance, in quality, and also in ranking, and try to solve those problems together. So in search growth, it is pretty interesting that there could be a contradiction between the volume and the user experience. So when the user do not find what they are looking for, they might be issuing another query by changing the query a little bit. So, when in the search results, the user didn't find the video he's looking for, he may click on a few more videos. So if you increase the number of volume of video plays. So there could be a contradiction between the experience and the short-term volume that we need to be super careful of. And the last area is advertising. So advertising, we're working on quality problems, trying to dig into the ad serving pipeline, because we receive some issues from our advertisers. So why my ad doesn't show, or why the performance is not good. So we have pipelines trying to dig into the entire serving pipeline from recall to different stages of ranking to pacing to figure out the problems throughout the pipeline. Into my current role, so currently I'm in WebXT under Microsoft. So WebXT is a consumer-facing function of Microsoft. As people know, Microsoft is mostly enterprise-facing. But in WebXT, we have 4 pillars of consumer-facing, including search, ads, Edge, browser, and also a news and feed. So here's the agenda for today's presentation. First, I'm going to start with an intro of the content understanding team, including the vision, the scope, and the roadmap of our team. The next section will be digging into the signals we produce. Because in content understanding, we are trying to produce a set of signals in our content for our downstream consumers to use. And we're going to look at the exact signals we are producing, and also showcase some demos and also the models we are currently using, and also some challenges we are facing. And the last section will be on business impact. So I'll talk about where in our business we can use the CU signals we produce. Also talk about the model onboarding procedure, and also showcase some impact results. So here is a little bit introduction to both the feed product and to our entire recommendation system architecture. So in the feed product, we are trying to build high quality, well understood feed content our users love and trust. And in content understanding within news and feed, we are trying to tag every piece of content with high quality and comprehensive CU signals. So our content include the MSN content. So these are brought to us by signed contract with our partners. We also have creator content. We also have content from the entire web corps. So the web corps content, this is brought on board through some vetting process. So instead of taking the billion scale web index, we actually reduce that to a much larger scale based on some human vetting process. So our content will be ingested into our index, and the first step we will go through is content moderation. So we try to remove the harmful content so they don't show up in the end user's feed. And content understanding essentially just enrich the content with the CU signals. So in content understanding, we have information from the market intelligence team. Those are local business focusing teams, so they may have understanding of publishers and also have understanding of the content's verticals or verticals. We also have editorial curation. So the historical system was based on editorial curation. So for example, the editor wants to curate a feed of coronavirus. So they will use some rules, including some rules on the tags and also the rules on publishers. So this is an editorial curated feed. So currently, with our CU signals, we are trying to replace the human curation process. So after understanding, there will be personalized retrieval and ranking. So everyone's familiar with. And what the feed is on in the UX is it will be on Windows, on our Edge browser, and on MSN, etc. And this is what the users see and engage with. So the charter of the team include 2 pillars. So the first pillar is content quality, and the second pillar is content understanding. So within the entire content understanding and moderation, we have the moderation, which is a separate piece, and the content quality. We are trying to tag our content with different quality signals. So internally, we divide content into 4 colors. So red means the harmful content we need to moderate. The gray means the low quality content. The ones with clickbait, the ones where the title is misleading and is not telling the truth. So these are the contents we label as gray content, and we are trying to demote those content within our feed. And then it's green, and the last one is gold. It's high quality content. We currently trying to mine our high quality content. So the mining mainly uses 2 philosophies. So one philosophy, of course, uses user feedback. Try to use users' feedback, including users' engagement with the content, and also the publishers to define our high quality content. And for another approach, we are trying to define traits, what we mean by high quality. Right? The content is newsworthy, the content is informative, or the content has some depth. So trying to build individual classifiers. The other pillar is what I mean by CU, like in the narrow sense. So here we are trying to do a topic classification. We are trying to extract entities, key phrases, and build clusters of our content corpus. So we are faced with multiple sources, as I mentioned. We have different content types, not just text, but also multimedia content. One challenge we have is we have global languages. So we start off with a multilingual model. Like we don't need to collect a training case from all the languages. But if we want to evaluate the model performance in certain language, then we need to collect measurement data on this language. And between English and non-English languages, it's easier to find cross sources to label English content rather than the non-English content. And we do have some challenges with getting enough non-English content and also getting a reliable measurement set for the non-English vocabulary. We also have multiple domains. So we have news, we have shopping, sports, and weather. So for our team, because it's horizontal, we are trying to support as many verticals as we can. But the verticals may go very deep into their own vertical. So we are trying to work from top down. Trying to have high-level classification of our content and then go to the next layer and then forward. But in verticals, they may focus very narrow in their vertical, and they do have very rich vocabulary within their own vertical. Some roadmap of CU. So in the near term, we are building capabilities. So we are trying to work on some foundational work to support the business. And this includes defining the guidelines. So once we have a new topic, like we need to figure out what this topic really means and how we can use the crowdsourcing to generate samples from this topic. And we need to have large-scale measurement set. So this is pretty critical. Once we have the large-scale measurement set, then we'll be off like training different models and try to have a fair comparison between different models. The dev cycle is pretty important. So we are constantly faced with refresh topics. Different teams may come to us and have requests. The local team is concerned with crime content on the local vertical. So like we often have a lot of content on crimes, and this could be one example where we raise ask. And with this new set of topics, we need to collect training and measurement set, and also build our classifiers. And we have a bad case handling process. So essentially, try to start from the bad cases, analyze and figure out where we can improve our model. So a lot of the ideas in the future work comes from analyzing the bad cases. So we do run a weekly meeting to learn the bad cases and internally understand how we can improve. A few examples include one is with multimedia content. So we realized for multimedia content, there is a lack of text. So to conquer this problem, we are trying to go in 2 steps. One is to take the existing text from the multimedia content. This is a low-hanging fruit. So we have video transcriptions, which we can use. We have image descriptions and captions we also can use. So this is obviously low-hanging fruit, and the next step will be to apply multi-modal understanding models that brings in the different models of media type. So currently we are still building the data, the use case, and the models. Try to accumulate different use cases. We are also leveraging the existing work. So previously, the CEO work has been pretty siloed in different teams. So we are trying to leverage the existing work and doing some comparison, doing some examples of existing models. So after the near term, going into the midterm, we want to start building the platform. So in platform, we'll be focusing on comprehensiveness, trying to come up with a comprehensive taxonomy, and try to come up with procedures where we can handle any free taxonomy. So we are currently approaching from a fixed taxonomy perspective. So essentially start with some taxonomy, and then we try to build models. But in the requirement we have is mostly free taxonomy. So they could come up with any topic we haven't seen before. So how do you deal with the infinite dimensional free taxonomy? We'll be building dashboards and analytics, and we want to be an open platform so that like there will be data and model repositories that is going to enable some collaborative efforts. We also focus on autonomy. The autonomy means both self-served model training. So the consumer team may have a problem. For example, they want to build a feed for World Cup in November, and they can label their own data, and we can offer some self-served model training pipeline so that with their label data, they can just directly come to our pipeline, and we'll have pre-training and with their data set appended so that they'll build better classifiers. And another aspect will be self-served signal consumption. So make this automated so it's easier for the downstream users to use our signals. In the long term, we want to contribute to the WebXT platform. We want to contribute to other businesses and also contribute to the external research community. So in terms of the existing signals we have, so for this particular example, this is an article with Victoria Beckham. So she explains why she just broke down at her Paris fashion show. So for this article, we have some basic signals, including the title, the URL, and the snippet. So currently, the snippet is generated by both AI and HI. So we have some. So we have a majority of the snippet generated by human, but with the missing parts, we are trying to use a snippet generation algorithm. We have classifications. So we have tier 2 and tier 1 and tier 2, essentially just high level and lower level based on a hierarchical taxonomy structure. We have free text. So the right-hand side shows the free text on this article. has been tagged with fashion style, celebrities, and clothing and apparels, etc. We also have extraction results, both key phrase extraction, like Victoria Beckham and the Paris Fashion Week. We also link the key phrase extractions to our internal Satori entity. So Satori entity is built on top of Wikipedia. And so we currently have a repository in the order of millions of entities. So by linking the key phrases to the entities, we can do ambiguation. Because the people's names, there will be ambiguations, and the entities will allow us to disambiguate. So take a quick look of the existing models. For tier 1, tier 2, this is a hierarchical taxonomy, and we currently use a multitask learning approach, combine tier 1, 2, and the free text. So these are the 3 separate tasks, and we try to combine them into a single multitask learning framework. So the model we use is pre-trained, and we use a transformer model. So currently, the model takes the title and snippet as input. In generating the training data for the 100K tags, we first have some free source data from Quora, from MSN, and also from Wikipedia. We try to use some mapping logic to define labels. So the problem with mapping logic is your mapping logic will dictate what the ground truth is. And simply by using the mapping logic, you might be learning the errors, and it will propagate. So we need to compensate this problem by having some additional human labeling, so that we won't just learning the errors throughout the mapping logic. For entity linkage, so this the current model is a modular model. So instead of taking it in the end-to-end task, go directly from our content to the entities, we currently take a stepwise approach. In the stepwise approach, we first extract entities. We first extract key phrases. So this is just a free-form key phrases, and then we do a search of the key phrase going into our entity repo. So essentially, just match the key phrases with what we have in the entity repo. We also have an interest in this model. The interest in this model is pretty critical. So we don't want to just get any entities of this article, but we want to have some sense of interestingness or salience. Okay, so in terms of the signal challenges, in the tier 1 and tier 2 model, we currently have around 13 categories in tier 1, and tier 2 is nested within tier 1 with a few hundred. And for tier 1, tier 2, we currently have like the following 3 challenges. One is to establish the topic level precision and recall measurement. So in addition to looking at the measurement in document level, we need to have topic level precision and recall measurements. The second is taxonomy quality. So we are trying to refine our taxonomy to be consistent with industry standards. And the last one is the vague labeling guidelines. So sometimes we need clarity on what we mean by this topic, and we'll consistently see when the guideline is not very clear, our model will fail, especially in those boundary conditions. For the tags, the volume is much higher, so we have 100K tags, and for this we have some granularity issues. We also have a pure semantic quality issue, and for this it's pretty challenging because you're faced with such a larger set of topics, like marrying topic level precision and recall will be pretty challenging. So in terms of key phrases, so we have seen issues both at the single phrase level. The single phrase level can mean the quality of the words and the quality of word breaking, all the way to duplication, like duplicating the different key phrases to improve the diversity and improving the informativeness of the key phrases, going from unigram, bigrams to longer key phrases, because the longer key phrases are typically more informative. We also want to look at between the key phrase and article pair, the relevance. And we also want to link the key phrases to the entities, because currently these two data sets, there's no clear linkage yet. Even though when building the entity models, we do have some linkage. So for entities, what we see is the precision is pretty good. So we evaluate the precision of entity extraction. So we have a precision of over 93%. But the coverage is not very great. Yeah, and another challenge with entities is the interestingness or the usefulness of any entity in the article. So additional challenges here, I'm listing a few additional challenges. One, of course, is budget approval for the operations, the human labeling, and the second is trait definition and guideline development. So for trait definition, it could be challenging even for the business to define certain traits. So we use an active learning procedure. Try to use active learning to collaboratively establish the guideline development. We do have a lot of external consultation overhead. And the last challenge I want to mention is ranking usage. So currently, ranking and the CEO operates in silos. So the CEO signal developed and then ranking uses. We want to build compelling use case so that ranking will use. But of course, this is pretty non-efficient, and we want to reduce the amount of turnaround time so that our signal will be used more quickly by the downstream users. Is this stuck? Okay, now let's go back to the last section. So it's on the use cases of our CEO signals, and also how do we bring our model on board, and some impact results we have seen. In terms of use cases, so we currently see use case in the following three categories. The first is explicit personalization. So we have some interest feed, and this is end consumer facing, so that the user will be able to see the feed, for example, under World Cup, under coronavirus. So the explicit personalization, this is a strong use case, and we have pretty high requirement on the quality of the CEO tagging in the explicit personalization case. For implicit use case, when we are discovering user interest, try to understand like a plethora of users' interest. So the tagging on the content side certainly is a good input to what the user's interest will be. A important use case is in content retrieval. So in content retrieval, we use both the interest-based retrieval, explicitly have a user profile interest, and we also have embedding-based retrieval. So So currently, the embedding-based retrieval uses both the content level characteristics and also uses the feedback from the end users, like user clicks, dislikes, to build our embedding. Like we have different retrieval paths for user-based and embedding-based. We also have CF retrieval paths. The last is analytics. So build some supply-demand dashboard to understand our content supply-demand and also to define the feed diversity metrics. In terms of model onboarding, we can have different strategies. One is to do a direct in-place replacement. So this is pretty quick, but it could cause life size in production. The second is to make the models in parallel so that they'll be A/B testable. And the last one is we can have self-served CO experiments. So we can take the initiative. So we'll have the function. We'll have the capability to directly experiment with our CO model improvements. A few factors to consider. The one is the measure of launch impact. Want to have some clarity on what's the launch impact of these new CO signals. So a challenge here is, of course, because CO is earlier in the pipeline, and the impact of CO, firstly, it will be diluted by the downstream processings and downstream models. And second, the CO impact could be a longer-term impact. Based on a multi-week A/B testing, so you may not be able to correctly measure the impact of the changes or the improvements in our CO tagging. We also want to be agile in improving models, but also be cognizant of the life-cycle health. So currently, we take a discrepancy measure between the old model and new model, and the measure can either be based on a set difference or based on some ordering-based discrepancy measure. So the impact metrics. So here I'm listing by use case. There were several areas, as I mentioned, and within area, like we have different use cases, and we keep track of the impact when we improve our models. So here I want to specifically call out is in recall. So in recall, we have a topic propensity model based on our 100K CO model, and even by this model, without collaborative filtering, we improve engagement by 1.25%. And a more recent one is the default topic recall. So for users with no history, like we want to have some default quote-unquote interest distribution of the user. So this default is based on our tier 1 model, and this results in 0.1 to 0.2% lift in the engagements. Okay, so this is a list of the work I'm presenting here. Of course, there's a lot of ongoing work. So both the work by the CO team trying to improve our CO signals with some collaboration with the research teams, and also trying to work closely with our ranking team to make sure the signals are used correctly, because we have seen cases where the signal has no problem, but how the ranking uses it may cause it to have no impact in the A/B test. So yeah, this is pretty much all about this presentation. Let me know if you have any questions.
Thank you.